Cool. Hi everyone. I just want to test if the volume is working. Right. That doesn't seem to be happening. Am I being heard? Two seconds. Some technical troubleshooting. Okay. Right. Let's test if I can get a different microphone to work. Hello? Is this working? No. No, that doesn't seem to be working. Hello? Hello? Just able to hear things. Okay. Hello? Hello? Okay. Sorry. Sorry, everyone. Yeah, this is working. Yeah. Okay. Sorry, there's an issue with my PC that meant I couldn't hear that I was at. So, fun. Let's get into the actual presentation here. So today, what we're going to be talking about is how to use GitHub. There will also be some extra information at the end of this presentation about the hackathon competition that will be taking place this year, and asking you guys for some feedback and some tips in terms of some future webinars that we're going to be running as an institution, and any feedback that you guys have about what you would like to see featured in those webinars. So the presentation today is going to be by myself, Jack Duncan. I am currently working as a data scientist in the NISR Big Data team. Some housekeeping for this presentation / webinar. So we'll run until 11 a.m. today. All questions will be answered at the end. I think I have a colleague helping me with managing the chat and managing the questions. When I finish the presentation, I'll kind of drop the presentation, read some of the questions in the chat, and I'll try to answer as many as possible that I can. The questions that I'm not able to answer in the time given, what we can do is we will make a Google Doc or something similar, which will link in the uploaded video of this presentation, so that as many as possible of those questions can be answered in a public forum. If you have anything else, I'll also have my email given at the end, where any questions, if you see this webinar after the fact, can be asked. And then finally, the slides will be shared afterwards in the description of the uploaded video. So don't worry about me flicking through the slides here today. I think it's going to be a bit of a mixture of me demonstrating things using GitHub, using the command line, and the presentation is more to kind of keep me on track. But the presentation does have all of this information written out, and so you can check that on your own time afterwards when the slides are shared. In terms of the webinar, so the contents of this presentation are first an introduction to version control, second, why we use version control, third, kind of what is Git and GitHub and why do we use them, how to link your computer to your GitHub account, using Git from the command line, using Git from GitHub Desktop, some general tips about using Git in GitHub, and then finally we'll end with some information about the hackathon and the discussion about future webinars. So jumping right in, a bit of an introduction to version control. So version control is a system that records changes to a file or set of files over time. This allows you to recall specific versions of these files later on. It primarily enables collaboration, it tracks your history, and helps manage project evolution. Some commonly used tools for version control include Git, SVN, and Mercurial. Today's discussion will revolve around Git and GitHub as a version control system, because these are some of the most widely used tools in data science and software development more generally. So first off, why do we want to use version control? So there are a few key reasons. It enables multiple people to work on the same project simultaneously without conflict. It keeps a history of the project's progress and allows easy reversion. Related to that, mistakes will happen with projects that you're working on, especially if you're working with multiple people. Version control lets you revert to a previous point with relative ease. And then finally, it also provides a clear overview of project development, including what changes were made, by whom and when. So when we're working on big projects, it can really be useful to understand if changes are made, kind of when they were made, who made them, and like what the purpose of that was. So what are Git and GitHub? So Git itself is a version control system. It's a software that kind of sits on your computer. It's a way to manage files and directories. It tracks these changes over time to those files and directories, and it allows you to recall previous versions of them. GitHub is a program built on top of Git to store your files online in a way that can be easily shared and worked on. So GitHub is essentially a wrapper for the Git functionality that exists on your local machine. GitHub primarily works using repositories, which are essentially online folders that you can upload and download from. So in the same way that in your documents folder on your local machine, you just have, let's say, a project or a Python app you're working on, these are just, that folder would just be called a repository in the Git terminal. So why do we use GitHub as a tool in data science? So First off, I think, as I said, GitHub is one of the most widely used software tools in data science. And I think that's primarily for three reasons. So the first is to do with safety. It's really important when you're working on projects to have them in a secure online location. GitHub is a great place to have this because they have lots of space that's available for free, and it's easy to use to back up your code relatively frequently whenever you're working on a project. Second is to do with transparency. So it makes it a lot easier to share code analysis with others. So this can include your team members, it can include stakeholders, it can include just the wider public. So this was a really big deal during COVID, for example, in the UK. There was lots of code analysis being done just by people in their spare time. And when they uploaded their code to GitHub, it was easy to check the work they'd done and to check the accuracy and validity of any claims. And the third is community. So this is kind of a wider point. It allows collaboration on projects within your team, which is really important, just so it's easier for you to share the things you're working on and be able to work together in a kind of seamless online environment. But also GitHub has a pretty thriving community which you can interact with and can help you with your projects if you do have any questions that aren't easily answered online or through your own research. So now we're going to start getting into the practical demonstration of how you kind of get set up with GitHub. So the first thing you want to do is get Git installed on your computer. This is pretty simple to Google and understand. And you just download the software and install it on your computer. You then need to register for a GitHub account. So again, this is pretty simple. I think it's covered in the webinar we did last year. And once you've got those two things set up, you're ready to move on to the stage of linking your computer to GitHub. So the first thing we want to do, and I'm using a Windows machine today, but the kind of functionality and the commands I'm using are, I think, identical across operating systems, though I have included resources on Linux and Mac in terms of how to use and set up GitHub at the end in the additional resources. So what we want to do on a Windows machine is open up our command prompt, which looks something like this for the first time. Then what we're going to do is type in git config global user.name. And here what you want to do is type in the username of the GitHub account that you've just set up. So this is mine. I think this gives an error because mine is already set up. I can then, once I've put in that, this should be accepted if it's your first time setting it up. We then have user email, which is the email used for your GitHub account. So mine is Mark W, which is fine. This is what it looks like when it gets accepted. And that's your computer now initially linked to your GitHub account. The next thing that I want to talk about is understanding the basic Git functions that we will be using on the command line here today. So the first one is git clone, the second one is git status, git add, git commit, git push, and git pull. You can see here the basic workflow of these different actions. So clone is the initial stage where we take a repository from GitHub onto our local machine. That's not shown here, but once we have the repository on our machine, whenever we make a change in the kind of working folder on our computer, we can use git status to check the status of all the files in that folder, and it'll tell us which ones have been modified or changed. We then want to add any changes we've made to move from the working directory to the staging directory. And once we're happy with any changes that we've added, we can git commit, which essentially saves it in our local machine. And you can add any messages there. So for example, if I was working on a chart, I might say git commit with the message new chart added, just so I know what is being covered in that commit. And finally, I can then push those changes up to the repository on GitHub so that it's stored online after I've made the changes. And what you'll be able to see in the GitHub version control history is any stage where there has been a separate commit alongside the message associated with that commit. So the first command that we want to talk about is git clone. So to use git clone, what we first have to do is set up a repository in GitHub. So we go to GitHub right here. This is the home page that you'll see. And right here, we can click new to create a new repository. So we're not going to use templates. We are just going to make a new repo. So let's call this demonstration repo as part of this. We can include a description of what a repository is for. So to demonstrate how to use basic GitHub functionality. This is an important point when you're setting up new repositories, is whether it's public or private. So if I'm working on a project that I'm doing in my own free time and I might want to share online afterwards, I'll make it public so that anyone can see it and anyone can kind of work with that code. If I'm working on something as part of my job, or for example, when I was at university and working on specific projects where other classmates might also be working on similar things, I would keep it private, just because you don't want to share anything that is proprietary or essentially not suitable for other people to see. For the purposes of this, we'll keep it public. We want to add a README file. So a README file just allows you to add longer descriptions of your projects. It's generally good practice to have a README which explains kind of what the project you're working on is doing, who's working on it, and you can also just add some things as you develop the project to explain what changes were made and how it's evolved over time. And then the final thing we want to add is a git ignore. So what git ignore does is it essentially tells your Git program not to track the changes of certain files. So when we're working in R or Python and using various like development tools, they'll generate a bunch of extra files that we don't really need to keep track of over time. And so this just defaults to getting rid of any of those files. So for this, we'll use the git ignore template for R, create the repository, and we can see this has just made the repository for us. Now to clone it, what we do, we click here on this code bit, and then copy the URL to our clipboard with HTTPS. We can now go back to our command prompt, and what we need to do is we initially go to the directory where we want this file to be stored. So CD is how you jump through directories in command prompt on Windows. And let's go to our documents folder, and we'll now use git clone followed by the URL to clone this repository onto my computer. So now if we go into my documents tab and we refresh this, you can see right here we have the demonstration repo with the README and the git ignore, which has the various R files not to check as it goes through. The next thing we want to do is git status. So git status tells us when a file has been changed and allows us to just check when we're working on a project which things we might have modified, and to double check that essentially we haven't changed anything we didn't want to. So to demonstrate Git status, what we can do is we can go in here and we can say testing Git status, and save this change to the README. Come in here. When you're working with the command line functions on Git, we always need to make sure we're in our repository that we want to be working on. So here I want to be in the demonstration repo, and then do Git status, and you can see that we've modified the README. Once we're happy with any changes that we've made, what we do next is git add and git commit. So with git add, we can either add specific files. So for example, I could do git add readme.md if I just want to add the one file change that I've made. What is more common is that you will add all the changes that you've made at any given time. And to do that, we can just use a full stop. Once we've added it to the staging area, we'll git commit the change, which again is like essentially acting as a save in our version control system. So git commit, and to add the message, you do git commit negative and then just in quotation marks whatever the message you want to add is. So demonstrating the changes from local machine. And we've now committed that change to our initial Git folder. The next stage is where we generate the access to be able to push things back up to GitHub from our local machine. So this involves a couple of steps, which is making what is called a personal access token. So a personal access token is essentially a unique password for your GitHub account that gives you access to be able to make changes to the online repository. In the presentation, I've got highlighted the specific steps you need to do. What I'll do is just talk you through it just now with a bit of a demonstration of how it works. So what you need to do is come into your GitHub account and click over here on the top right where your profile is. What we do is we go to settings. Once you're in settings, you scroll down, and on the left-hand side, there should be this thing called developer settings. Within developer settings, there's now the option for personal access tokens, and we want to choose tokens classic. What you can see is I already have some personal access tokens. This gives me my access to be able to upload to my own GitHub account from this computer. And what we'll do is we will generate a new token to be used. So let's say demonstration token. The expiry date on these depends on the sensitivity of what you're working on. Generally, it is good practice to have the expiry date in this sort of 1 month to 3 months range, just in case someone was ever able to gain access to your GitHub account. It could be quite damaging if they were able to change your files without you realizing. So no expiration is generally like quite bad practice. So let's set this one up for 30 days. We then want to give it rights for the repository. So this allows us to essentially use all these basic commands to access repositories and upload and download from GitHub. None of the other ones are particularly important. And then we generate this token. Once you've generated the token, you'll see this. And what this is essentially the password that is generated by the token is just this key. So what you need to do is you need to copy this to your clipboard, and somewhere secure on your computer, you want to save that personal access token so that you can use it whenever you're working on your GitHub project. project. So I would save this as a personal access token. And what we can do now is, once we have this, when we do our first ever Git push, what you would see is then what you will be prompted to do is to log into your GitHub account using your personal access token. So for me, this won't work. Mine will just automatically work because I've already linked my computer. But when you're doing your own project, what should happen is a prompt screen will come up and you just put in that personal access token password. Once you've gotten the push rights for your computer, you should also then delete the personal access token that you've just made. So for this stage, you can also choose to just essentially go from like this screen to getting the push rights. That also works. But or just making sure it's in a very secure location that someone will not be able to gain access to, because again, these are very important. And I'll be deleting this one afterwards so that people can't gain access to my account. Next command, and this is the last command that we're going to be learning about today, is git pull. So git pull is literally the opposite of git push. So when we use git push, we are pushing a change from our local machine up to the online repository. Git pull is pulling any changes from the online repository onto our local machine. So I can demonstrate this by hopping into the demonstration repo. And what we can do is we can go into the README and edit the file directly in GitHub. So testing git pull using online change. And what we can do is just commit this change directly to our repository. In general, it's quite bad practice to do this directly in GitHub, but for demonstration purposes, it's a bit easier. The most likely instance of using git pull is if you're working on a project across multiple machines, and so you might push the change from one machine and pull it down on the other. Or if you're working with multiple people on a project, as each person makes changes, you always want to pull and make sure you're working on the latest version of the project. So now what we can do is come into our command line, use git pull, and you can see that it's added 2 lines to the README file on the local machine. And if we come in, you can see that change that I just made on GitHub is now in our local repository. The next thing that I'm going to talk about is using GitHub Desktop. So it is really important to understand and be able to use the command line. It gives you a much more fundamental understanding of how Git works, even though it might not necessarily be the most intuitive in terms of a user design function. However, what we can do as well is we can use GitHub Desktop to manage changes. So this is an additional tool provided by GitHub for free. You can just download it onto your computer and get it set up and link it with your GitHub account, and essentially wraps all of this functionality that we've learned on the command line in a much more easy to use way. Additionally, some interactive development environments, so things like RStudio, SugarLab, VS Code, also have their own built-in GitHub integrations. GitHub Desktop is usable across any sort of interactive development environment. It sits behind that once you've got a folder set up to be able to upload, pull, or commit changes. So what we're going to do is now just do the exact same functionality, but using GitHub to demonstrate how it works. So what we'll do is we can go to the GitHub Desktop app, and I should be able to see if I add an existing repository. I have demonstration repo. select and add. We can see the demonstration repo here is now in the GitHub desktop app right here on the left-hand side. What we'll do now is we will make a change to the README. So test change for GitHub desktop and save that. When we come into GitHub desktop, we can now see that there's been a change to a file, and you can see the changes that have been made. So we've added these two lines with the kind of blank line, and then the test change for GitHub desktop. Now, GitHub desktop basically adds, this is essentially the status functionality that you can see. Here, what we can do is essentially add and commit at the same time. So here I want to say tested change for GitHub desktop commit. And then we can just commit this to main. So now that commit has been saved. And then finally, either here or here, we can choose to push that change up to the GitHub account online. And so essentially those individual commands that we just learned, but it's much simpler in terms of how it looks and how it works. And again, we can go here, refresh our online repository, and you can see the test change for GitHub desktop has been uploaded. We'll just quickly show again how it works for the pull, which is the last functionality. Test change pull desktop. Commit this change, and then come into GitHub desktop, click on fetch origin, which essentially just checks that the local is the same, and we can see that we need to pull because we're behind. So let's just pull that change. And once that's finished, if we come into the local, we can again see that the change has been made coming down from the online repository. Yep, covered all that. Now, the last thing I want to talk about in terms of Git in GitHub is putting existing projects into repositories. So this is quite important if, for example, you may have already worked on a lot of projects that you want to upload to GitHub, but you weren't sure how to do it in the best way. Or if you just start working on something, not realizing that you maybe want to have it stored online, and how you can do that after the fact. So the best way to do this is to make a new empty repository in the language we're using for our project. So for example, let's say that I've made the demonstration repository after working on something. So let's say it is this, sorry, I have various projects. Let's say it was this file, and if we go into demonstration repo and essentially just copy this file over, then we can quickly go to our command line, git add, adding files from my existing project. Oh, sorry, I used the wrong brackets. And then git push this, we can essentially go from having our project just housed on our local machine to now having it in an online location as needed, and can continue working on the project just the exact same workflow as demonstrated before, with Git now set up. And again, just to show the functionality of how this works, we can come into the commits and you can see the initial commit demonstrating the change, updating the README. These two are the changes directly on GitHub. And then test the change for GitHub desktop, adding files from my existing project. And what we can do as well is at any point, we could essentially come in here and be able to revert to one of these changes. Um, the last thing I want to talk about in terms of the GitHub stuff is some general tips. So firstly, you should commit any changes you've made at the end of each day, or ideally more frequently. So whenever I'm working on a project and I make a significant change, so like I was saying before, if I was working on a project that required multiple charts, I would probably commit after making each chart um, as part of that functionality. Or if I was working on a big project that had multiple aspects, I made any change that impacts on different files or different folders, making sure that I commit at each stage so that if something stops working, we're able to identify at which point the change was made that broke the initial code. Secondly, if you're doing a public facing project, make sure the data being used in your analysis is linked in your code. This is generally good practice as part of transparency and just making sure you're doing repeatable or replicatable code, which is in general just quite good practice. Third is to use GitHub for personal projects as much as possible so you can help build your skills and understanding. GitHub really is one of the core technologies when you're working in the data science field. Having some examples you can point to of using it previously is going to be super important for when you're looking for a job and just more generally for when you're working because it is a genuinely useful tool. And lastly, explore GitHub for topics you're interested in. So there are lots of really cool resources available for lots of topics on GitHub. There are some really smart people working on really interesting things, and a lot of them are much more available than you might expect. So if you do see someone doing something cool, really feel free to leave a comment or try and message them directly just to see how you can get involved or if you can learn anything from them. I think in general, people really are willing to help if you demonstrate genuine interest in the topics that they're interested in. Great. So that's the end of the information or the GitHub webinar itself. What I'm going to do now is just talk about the hackathon that's coming up this year and also some of the future webinars that we'll be running as part of the hackathon and like general outreach that we're doing here at NISR. So the next NISR hackathon will be taking place over the summer. We expect it will run from roughly the middle of July until the first week in September, which is when the bootcamp will be held. We are still deciding what the topic and the competition will be. So last year, for those of you who participated, you'll know that we did a dashboard competition using the economic statistics that are regularly published by NISR. We wanted you to do that in R and Python. We are open to suggestions on the exact kind of topic or competition you would like to compete in. And any feedback around that point is extremely welcome. Entries will be allowed from current university undergraduates and master's students. I think this is the same requirement as last year. So if you are a university undergrad or master's student, please keep your kind of eyes open for any information we'll be sending around about this. We really do want as many of you as possible to compete in our competition. And just lastly, that knowing how to use GitHub will for sure be a part of this competition. So do review the materials that are being made available through this webinar and kind of work on your skills in advance of the competition because it will really help you not like being able to compete without having to worry about how these things work at the time. And finally, so future webinars, as I just said, we want to host more of these before the hackathon begins. I think we're aiming to have at least 2. We could expand that depending on availability and timings. Some potential ideas for these include how to deliver and design a presentation. So last year, as part of the bootcamp, giving a presentation was a large part of the final assessment. And I think some tips and tricks around that might be quite helpful. The second one is less relevant to the hackathon itself, but it's just quite a cool thing to know, which is how to build your own website using GitHub Pages. So GitHub Pages allows you to have a static website hosted for free. What lots of people use this for is either a place to have their CV and some information about themselves, or they can host some personal writing and personal projects to demonstrate their interests and skills in either data science or other topics. And third one that I've thought about is an introduction to data visualization. So obviously when we're working in data science, being able to communicate your message is a huge part of the work you do. And one of the key tools for that is visualizing your data to demonstrate to stakeholders. It's also really useful for data visualization to know how to use some of the like initial tools so you can understand the data better yourself when you're doing your scoping and your initial analysis. And yeah, in the comments or to my email, please suggest any other things that you might want to learn about in a webinar. We will really try our best to have that covered. Here are some additional resources I've put together for people to look at on their own time. So there's a general introduction to Git and GitHub, how to use Git on Linux and Mac, and then a couple of points around using GitHub in RStudio and Jupyter Lab. And that's the end of the presentation today. So if you do have any questions, please put them in the chat. I'll try to answer as many as possible just now in the time that we have. If you are watching this after things have been broadcast, or if there's something that I didn't cover but you still want answered, please feel free to email me at the email displayed there, which is jack.duncan@nisr.gov.rw. Thanks, guys, and I'll now probably stop sharing screen and just have a look at the chat. And if there aren't any questions, I will probably end the stream in the next 2 minutes. Cool. Okay. I don't think there's anything immediately jumping out. As I said, please keep engaged with us and do reach out if you have any information that you want to give or anything for the future. Yeah, and thanks to all that attended.